In this video, I'm going to teach you about what are all the components involved in an SAP PI PO component and how do these things work together. It's a lot. This video is a part of my PI course training that teaches you a lot about PI. So I wanted to make this first module free so you can get an understanding about how I'm teaching and what the component PI PO is about and what people are talking about when they're dealing with this. So I hope you enjoyed this video. Hey, and welcome to this PI course where we'll have a look at what SAP PI is, PO, and what the whole platform is about. So I'm really thrilled that you're here and you've decided to learn together with me in this journey. I do hope you take a lot away from this that you can use in your own experience and creating your own interfaces. So this first module here is about getting started and figuring out what PI is all about, trying to put all of the things together in a concept that is a little easier to understand. I know I'll be referring to a lot of different components in this video, and a lot of these would be recapped later in the coming module. So if you don't get it all, it's okay. You'd be able to pick up some of these things later. I've been working with SAP Integration, XI, PI since 2004. So there's been a lot of development going on, and I've updated this document or this training to focus on PI 7.5, but most of these things is also applicable to 7.31 SP1 enhancement packet 1, where you got the Java only. So the Java only is what I'm focusing on right in here, but I do refer to some of the dual stack options where you're using the ABAP also and what that does. So let's get started with this. So hopefully this will give you an idea about how SAP PI works. What are the components? What are the terms that we're using to describe what's going on in this landscape? So the agenda I'll be sharing is a little about the basics. We're talking about what are the architecture we're having, what are the components involved in this, and then we'd have a look at what are the objects we have. So it's a lot of things to cover, but keep in mind all of these would be covered more detailed in the later chapter. But you need this overview about understanding all the things, otherwise it'll be a little too complex to understand what's going on. So PI is the focus area, and PI consists of two things. It's an enterprise service bus and ESB. It's enterprise service bus is a concept where you can put a message, it would be persisted there, and then it's this bus responsibility to deliver the message wherever it needs to be delivered. The PI it's a platform you can use to integrate with other systems, process integration, and the key selling point behind the PI has been its excellent integration with other SAP systems. So you got a lot of native communications going on with the SAP systems. So there's some main project groups that we're going on when we're talking about integration and where the PI makes sense. So there's the A2A application, which is application to application integration. You got B2B application, which is more expanding reach out to third party or customer vendors and expanding your business network. and well, A2A, application to application, could also be from your SAP system on premise to a cloud application, because in that perspective it would still be, in my book, it would still be a application you're communicating with. You got the ETL extract, transfer, form and load application that is going on, where you want to have big data loads, and then you got the managed file transfer, where you're just moving files around. So PI is primarily targeted at the two top ones, B2B and A2A, whereas it can do the other things, but it's not the main focus of the applications, and there's other tools that is better suitable for that. But for some scenarios, it might make sense to use these things. So why do you want to use SAP PI? So one of the cool things about it is it's easy to do mappings. You got a good overview about the source document and the target document, and you have a graphical mapping tool that allow you to connect these things together so they're easy to use. It enables you to connect with multiple different protocols, so there's a lot of adapters built into the system that you get for free or as a part of the license file. SOAP, REST, OData, JDBC, MQ, DMS. So all of these give you the ability to connect to different systems. And then you got the native SAP integration for IDOC, RFCs, IDOC, RFC, and proxy calls, which is a SOAP, extended SOAP protocol. And then the PI is really good at processing single messages. This is the enterprise bus concept, where you're just delivering a lot of messages, and these are being delivered, routed independently of all the other ones. So you don't have any state handling in it. So it's just deliver a message to whoever needs that message. So when should you not use PI? ETL scenarios. So some of the things that the PI is not good at is handling large message sizes. So you have messages ranging above 100 megabytes. You need to consider whether or not the PI is a good tool for it. If it can just move this file without doing any conversion in it, it can be okay. And there's definitely been some improvement in the Java stack for handling larger message sizes. Some problems I've seen with ETL is if you have a flat file, you convert it to XML, it suddenly explodes the file, and then you get a file that's 3 times, 5 times as big. You have to do all the conversion of it, and that can impact the system, because you got a big chunk of data that needs to be mapped with a lot of overhead and collapsing. So ETL and big data loads may not be the best data to use, and then also huge data volumes is not ideal for it. I have seen scenario where it has been used, and where you want to avoid getting a separate ETL tool. Then obviously it's okay, as long as you know how it suits, and maybe you want to do some performance tuning on this. So it's this loosely coupling system, and back in 2004, the big thing people were talking about was this service-oriented architecture, where you had a decoupling of systems. So you would be able to just say all our systems need to support a standard customer definition, a standard order definition, a standard whatever this definition, And then the goal was that you would say, oh, we changed our HR system, so now we just get a new system, and it supports the same interface, so we can just reuse that one. I guess that was SAP's vision for it, that you'd get a common data type across all systems that were defining these things, and with that was built atop of the service-oriented architecture. It does really sound good in practice that you get this reuse and not dependent on which systems you have, and you can remove and swap them as you like. In practice, I have not seen that as useful in most situations. I have seen systems, or sometimes when we have defined an interface, for instance, for a warehouse system, and we had a common warehouse definitions, and we had multiple different warehouses, we were able to swap warehouses, warehouse software out, and it worked, but it is not something that you see in a lot of cases, because most integration is still done kind of point to point, but you obviously want to make sure that you have an idea, is this something that could be spawned to use multiple different, for instance, warehouse systems. So what are the components that we have in the PI? So it's a little difficult getting all of these things ordered in a way. So the user is accessing the enterprise service builder. There's two components to this. There's the builder that would create content. This is kind of like code. You're defining what are the interfaces, what are the mappings, transformation we want to run. And then we got a directory part, which is how this thing should work. So this is all the configuration that's being done. This is all done by the user. We got an SLD, that's a system landscape directory. This information feeds in, stores information about what you have in your system, how it works, what kind of. So in the SLD you have information about what kind of business systems you have in your system, what kind of technical systems you have, and what kind of software component and products you have. And this is not, well, it's used for organizing where components are. And when you get to the runtime component, Adapter Engine Advanced, Java only stack, it would sometimes get information from the SLD to figure out where it should deliver messages to, and how different components were stacked together. And then you have some business systems that's also created down here, and this interacting together with the Adapter Engine. So let's have a little talk about how the PI architecture works. So there's been a lot of changes going on, but the main part is the Java only. That's the part that's come to stay. It started as the single stack option that you were able to only install a Java system, came from 731 730 enhancement package 1. I think in 730 and maybe in 711 there was some options for running scenarios only in the Java systems, but it was not possible to install a full system, and I haven't seen it used that much. So when we're talking about this, we're talking about mostly 731. That is the base component that we're running on. Can't remember, I think it was from 2012 or 11 this was released. Then you got the 7.4, and it is exactly the same with functionality and components as 731. The only difference is it's able to use the HANA database as a database. And I think there's something like 5 service packs difference between them. So most of the features is in both of them. I think lately some of the new features is only being developed to 7.4. I'm not sure on exactly if everything is being developed for 7.31. But I think a lot of customers still using it, and obviously also previous versions. So when we're talking about the HANA database, it doesn't really have any effect on the PI. So you just want to do this if you want to have a database condensation and don't want to have consolidation and don't want to have too many database providers in your system. 750 was released, I think, late 2015, beginning 2016. The main difference here is it's using Java 8. I think when you're installing it, it only has a Java-only installation option. So if you're upgrading from a 7.31 to it, it would separate your ABAP instance out to a separate system ID. And some people have successfully deleted this Java instance, so you were able to upgrade it, delete the ABAP instance, and then you would have a running PO system. New installations is not possible with ABAP. And I think this is the recommended version as of now because it's the latest. It's quite stable, so it has at least 1.5 years of running time. And I think the big thing that's different is the iFlow support is a lot better now. Another concept that messes this thing up is about PI versus PO. So PI is process integration, PO is process orchestration. So this course would mainly focus on the PI, which is the message broker. But if you have PO, then it doesn't mean that you would not be able to use the course. So the PO obviously consists of the PI. So you still have the same messaging capabilities as the PI system has. Then it has a lot of more functionalities. So you have a BPM, business modeling framework, where you can run processes in and make sure they run as you want them to do. So this is if you want to run more complex scenarios. In PI and in Java Stack, you also had the capability to do this using another modeling framework that was not as complex. It was not as sophisticated and didn't have all the capabilities that this BPMN new modeling framework has. And the new modeling framework is also faster, so you can run it without having to be as fearful as running these old things. So there's a BRM component. This is business rules, where you have the ability to define rules that the business can edit themselves without you having to be involved in these things. So there's a nice UI. You can go through, edit these rules and figure out what should be there. There's also a portal component, and I think this is used so you can expose some of the BPM task. If you want to create user tasks, you can create them there. There's a B2B add-on. Previously on PI, you had to use a third-party component, so most people would there use Seaburger's B2B add-on. And Seaburger gave some ability to convert Inteface and X12 messages to XML and some of the tools around that. This is included in the PO license, so you get that as a part of license and can use it. Then there's 2 more services that is left that's not, they're a little different, but at least it's also something that runs on the platform. One is the SAP Cloud Platform Integration, previously called HANA Cloud Integration, that has a runtime capability here. So if you have some of these scenarios and want to run them locally, you can run them using this tool. Then the other thing is also you have the ability to expose data using OData. So SAP NetWeaver Gateway, you would create them in the ABAP runtime, and then you just expose it. And from a PI perspective, or from the Java stack, you would then be able to expose these services, so users would be able to access them. So we talked about what was the old framework versus the new framework. So in the previous, you had an adapter framework. This was so here we have the Java stack. So in the adapter framework, for instance, if you have a file adapter, it would read the file. Then you have some message processing going on here. It would then send the message in to the integration engine. And here we'll do routing and figure out where the message should be delivered. We'd find an interface. And then if you want to do a mapping, it would send the message back into the Java stack, perform the mapping, get a response back from this mapping, and then it would send it up to the adapter framework again for processing. So that meant we had quite a few times where we had to send message using the internal TCP/IP protocol between the systems. There was persistence, so each time you had to switch layer, you had to persist the message to make sure you had rollback points and stuff like that. So that hindered the performance also. The main reason why this was useful was because some of the adapters only supported the ABAP runtime. So this was the proxy adapter. This was the IDOC adapter that needed to feed data into the integration engine directly, and the HTTP adapter also. And these would also be able to process over here. So some scenarios you'd use the ABAP, the Java to send messages. Other you'd use the ABAP to send messages. And if you had to do a process, a CC/BPM, you would have to send it into the CC/BPM component that would run it, send messages back, and go through the flow again. So this was not an ideal flow. It had some capability. It was performing okay, but you had to do tuning in 2 different systems to get optimal performance, and it was not ideal solution for an integration broker. So what they did was they created a Java only single stack where you have the adapter framework. You would be able to have your routing, figure out which mapping you wanted to use, and which then will go to the receiver and being processed there. And you also had the processing capability, and this was actually just messages coming through the adapter framework, sending this using a proxy, SOAP protocol. So all of this was, so the service process orchestration was actually just a web service you could invoke and get the services it provided. But one of the benefits here is obviously you don't have that many save points, you just have a save point here, and then everything else can be processed seamlessly. So it's a lot simpler, a lot easier to run framework, and a lot faster. I think they were saying something like a factor of 10 times better performing using this adapter only approach when they originally released it. So let's have a look at the adapter. So it is Java based. At least for our perspective, this is Java based, because, well, the ABAP adapters is deprecated now, and if you have them and you're doing migration, you need to get away from these. They enable systems to communicate with each other. So they can receive messages from connected system, and they can send messages to connected system. So this send and receive often gives problems, because you would say the message would receive from connected system, and it would then send it. So, but this would be the difference, because it would be a sending adapter that would receive the message from a third-party system. But we'll cover that later. So that's a little of terminology that makes this a little difficult. And then development. So whenever you are doing your development, you obviously need to consider what are the adapter we are communicating with. Sometimes it's okay, because if it's just an XML document, you can send, and if it's using file, HTTP, it doesn't matter. But in some cases, the adapter has specific metadata that's required for it to run. So this could be the database JDBC connector. Here you have a specific structure you want to call whenever you're calling this system. There's also obviously you need to know what are the data structure that you want to call there. IDOC, it's also important. So this is something that needs to go into the design requirement, which adapter you're supposed to be using for this. When, for instance, we are processing a file, there's a pipeline that we can put modules into. So a pipeline is, so the first thing that we'll do, for instance, if we have a file adapter, it would process the adapter every 1 minute. It would look in a specific directory to say, do we have any files in this? And if it does, it would start processing the file. It would read the file up, and it will do all the conversion that happens internally in this adapter. Then you can put in a set of modules that can be used to perform specific duties on this message. So there's some standard modules that will enable you to do locking, that can save whatever message you have, that can swap the payload. You can create your own modules to do specific XML conversion, save messages in a different way. So this gives you a really good way to get more information about what's going on in the system. And then you can just put these into the queue and process them, and it will be processed every time a message is sent. It'll process module 1, it'll process module 2, and then the message would be sent to the pipeline for further processing. I was briefly mentioning this sender-receiver concept and what it was, and it sometimes gets confusing to understand about. So what we're saying is the communication we're defining in the PI system all correlates to what system we are trying to interact with. So the sending system, this is the system where we receive the message from. This is using the sender adapter. So the sender adapter starts reading if it gets a file or it gets triggered by a web service call, for instance. On this, you're defining an outbound service interface, and outbound is also referring to the information that you're getting from the system. Similarly, on the receiver system, we have a receiver message. So the receiving system receives the message. And here we have an inbound system that is So we're defining the inbound as what this receiving system expects the message to be like. So the only thing you need to understand is we're not looking, when we're defining a scenario in PI, we're not looking at the PI, but we're looking at the systems connecting to this. And there's some ways you can see if it works and if you're doing it the right way. If you have a file adapter, you can see, does this file adapter write or does this file adapter pull? So if it pulls, it would read every 5-10 minutes. And then you know it is coming from the sender system, because this would be messages that is coming in and we're processing one by one. XML is used to handle all messages in the PI system. So it's the main way you're dealing with messages. And the way it's normally being used. So it's mostly defined by XSD. I think earlier some people were also using a data DTD for it, but I haven't seen those actually for quite a few years. So most messages would be formed by an XSD, and an XSD is a description about what format we're expecting, how does this work out. And then you got the VSTL, which is including an XSD plus some more information on it. It's easy to agree to share a format and agree about what is the message definition that we're going to send. It becomes a lot more difficult if we wanted to agree on the content that's coming into this document. So we can all agree that this is the service order or this invoice number. But once you get into more detailed specific country, business organizations, or it becomes a lot more complex about understanding what are the messages that are going in through this. So there it becomes a little more complicated about figuring out what is going on. So that would be a place where standard organizations or governments are involved and would create a document saying this is how we expect your documents to look like. So obviously it becomes a little complex and figure out where all of these things fit together. So here we have an example of an XML document. We have a root element, and this root element is ended down here, and we can see we got this slash that indicates that this element is closing. So all elements must be closed. You can define an element without closing it. If you don't have any content for it, for instance, if the two, we would just write 2 / and then this bracket. That way we would not be able to have any content in here. We can define multiple lines. We have attributes that we can look into this. And on top we have a definition about what is the XML document. We could have a definition about what are the encoding we want to use in this document and stuff like that. So this gives the document an understandable way to handle what's going on. We have a concept about mapping, and mapping takes data from one format and translate it to a new format. Most often we would use the graphical mapping tool for transformation, but in some cases you would also be able to use XSLT and ABAP or Java, because they're giving you some features either generically or specifically that you don't get in the graphical mapping tool. So sometimes if I have to order a document, I would use an XSLT, because if I wanted to use the graphical mapping tool, it would be rather complex to do it. Java also have some options for namespace conversion, stuff like that. In the dual stack environment, you had the option to have ABAP and ABAP XSL, But obviously, since the since the ABAP stack is going away, it doesn't really make a lot of sense to keep using it. And if you have them, you need to move away from them. Graphical mapping, it contains a lot of built-in functionalities for concatenating two elements, for string comparison, for managing elements at different levels. So if you want to copy the order number to each line item, you can do that using this tool. So then it becomes a little more complex. There's a queue and context concept. We'll look more into this later. That's one of the key things that you must be able to master, because if you're creating more complex mappings, it becomes rather complex to understand what these kind of queues and context means. And then you can create your own functions in this. If you want something specific that's not provided with the standard, then these are ways to make it easier to run the PO system. So here we have an example of a mapping. We can see we have the source document, so this is the message that we're getting in, and here we have the target document, and we can see we're currently looking at this element here, and we can see we have some elements that's being used, and we can see what are the data that's coming in here. We can see we have defined some some libraries with user-defined functions, and we can see what is going on here, and we can have, so each component can have multiple places where it's sending message also. So previously, if you wanted to copy something, or if you wanted to get this to two different elements, you had to create each element and copy all of this information, paste it in. So with this, it becomes a little more readable and a little faster performing, that you can put all of them into one queue, and then when it gets all of this information, it can populate multiple different fields with it. So, business understanding. I think this is one of the key concepts about PI. So we have two things. We have the technical competency about understanding about what this full platform is about, what we're dealing with. And then we got the business understanding about this. So obviously, as a technical eye, you're not able to understand what the full process that's going on here. How does this payment work, and why do we have all of these settings going on in this payment? And you just have to figure out what the business is saying. The challenge is, most of the time, the business don't know how we should perform the mapping. So they would say, we want to convert from this document to this document, but they don't really know how they connect to each other, and what are the benefit of using one versus the other. So in some time, you as a PI developer need to play this role about figuring out, is this correct? And especially if you have a standard document like a B2B standard, the business guys may not always know these things, so you have to challenge the business, saying, hey, we got this field, where can I get this from the document? So this is something you have to do as a developer. If the business give you a mapping that says these are the fields we need to map, you have to map them, and then you have to look at the document and see, are there anything else we would need for this to work, especially if it's like, a standard you cannot do any testing on. If you're able to test it, obviously in a test you would see, we cannot create the order in the target system because we're missing these fields, and then you have to ask, so how do we find whatever specific information that we're getting from this? But you have to guess that sometimes they don't have all the answers, so you have to figure out where you'll be able to get these data yourself. So it's not easy, but I guess it's just the reality that you have to figure out how this works, how your business, how all of these components work together. So there's a lot of objects that we are going to cover, and they have some interaction, and they're relating to each other in specific formats. So, and you must know what they are and how they relate to each other. So first off, we will look at object placement. We'll cover this more in detail later. So we have a software component version. This is defined in the SLD, a system landscape directory. Then we would create a namespace where we'll be able to organize our components into something like a URN or HTTP. And then under this, we would be able to put in our specific objects. So this is the start screen that you then have about what are the different tools. So here we have the enterprise service repository. Here we have the SLD access. Here we have the directory. And then we have the configuration part here. So in the repository, we have structural information. So this is information about what the message should look like. So this is XSD, VSTL description about what's going on. We have mappings about how to transform these documents, either the graphical, XSD, or Java mappings. Then we have processes around this. So this would be, at least in the old world, we had processes here, we could define them. In NetWeaver BPM, you're defining in NetWeaver Developer Studio. So there's a lot of governing taking place in here about making sure that we're using the correct naming of these objects, that they relate correctly and they develop correctly. And the thing here is these are developed once and then they're transported through the landscape. So and they should be identical across multiple different landscapes. So once you have a document, it should be the same in all the other components you have. The directory, on the other hand, is kind of different in each system, and the logical reason for this is obviously your test system is called something differently than your productive system, and you want to use it differently. So that's why they're called in different. You need to configure them in the different systems, and then you're configuring the flows between them. And often the flows should obviously be the same. But sometimes you may want to have different configuration going on in each system. And then you have the iFlows. That's if you're creating iFlows in NetWeaver Developer Studio, they're deployed as integrated configurations. So if we look at the repository, what are the objects we have here? So if we have a message, would be the message that we would be receiving. So here we would have the sending system. So this would be the outbound interface of the sending component. We would have an operation, we would have message type. Message type you would define in the PI system, and the same with service interfaces, operations. And then you have data types that's also defined in the PI system. So this is PI's way of modifying messages. You could also use an external definition that would be either a VSTL or an XSD, and obviously sometimes you would have the DTD, but I haven't seen those for quite a few years, so I doubt you would get those. So this is XSD, and then you have conversion between these at the operation level. So you're having operation mapping that would convert from with this layer. There's a message type where we would convert from the message to an external definition of the message. And then you can also use imported archives to do this conversion of messages. So actually, if you are using it on a service operation level, you don't need to have defined what's going on in this external definition for real. Because if you're just using an XST, you can use dummy definitions in each of these, and the system would not care about it. But obviously, if you want to do it, it's not that ideal. On configuration side, we got a business system. Business system is a real system that you have in the landscape you have created in your SLD. On this, you are creating a communication channel. Then you have the integrated configuration. This is the interface. You have an operation mapping, and then you have an interface for the receiving system. And here you have a communication channel also, but you could also use parties, and we'll cover that later. Party is if you want to deal with, for instance, UBS or MasterCard. You define them as a party because they're a specific business entity that you want to deal with. And here you define a business component because it's not any system you have in your own landscape. And if we look at the system landscape directory, then we would have the technical system. So this is a real system that you have. You have your development PI system, development ERP system. These are technical systems. And then you create business systems on top of these. That is, for instance, if it's the ERP, you would have a ERP development client 100 as your business system. That's collecting what are the software component version we have on this. And then you got the namespaces and repository objects in this. Don't worry, we'll cover this later. Just wanted to give you these slides. So next I'll show you how you can use the system to create a real scenario. I hope you learned a lot. I know this was really a lot of things to take in and a lot of concepts to understand. In the next video I've created in this series, and also from the PI course, is a video that teaches you how you can actually create your first scenario from end to end using a file communication channel, creating data object mappings and configuring it all. So you can get this video by signing up to picourse.com, or go to picourse.com, sign up for the free video, then you'll get this next video tomorrow. Or if you're all ready to learn more about this, then go to picourse.com and buy the PI course and learn how all of these things to work together, because there we're going into a lot more details about all the different components, so you really get to understand how they work.